Hi everyone, let's have a look at Chapter 7's Part 3. So we're looking at the maturity value or the future value. Okay, so in the last two sections, what we looked at was interest, we looked at principal, rate, and term. And the last question that we did where we had to figure out the flexible or the variable interest. And then in the end, it wanted to know what was the total amount that was due on the due date of the loan. So that included not only the interest, but also the principal amount. And the two amounts put together is what we call the maturity value or the future value. So it is the total of the original principal plus the interest that's due on the maturity date. And this is represented by an S. Okay, so the basic formula for the maturity value is S. So the maturity value or the future value equals principal plus interest. Okay, and you remember how we just calculated the interest in the last two sections, I equals PRT. So we're including the first part that we calculated, which is the I, and now we're adding in the original principal amount that was borrowed to give us the total future value. And what we're going to do is we're going to rewrite the formula. So instead of it being principal plus interest, we're going to figure it out as principal plus, and then the value of the PRT. And we can simplify that equation by combining like terms and taking the P out of the brackets so that your future value equals your principal, and that gets multiplied by 1 plus RT, which is your rate in your term. Okay, and 1 plus RT, multiply that by the principal, gives you the future value or the maturity value of that loan. So it's the same formula. You're calculating the interest, you're adding in the principal to figure out what the total maturity value is. So take a minute and try this question, okay? You borrowed $2,000, so that's your principal, for 8 months at a simple interest rate of 5%. PA stands for per annum or per year. What is the maturity value of the loan? So again, we could do like we did the last time, figured out what the I is, I equals PRT, then add the principal amount to it to give us what our maturity value is, or we could simplify that by, again, the formula being P, and then in brackets, 1 plus RT. Okay, so and you can try both formulas if you'd like to see how they do calculate the exact same amount. So take a couple of minutes, pause the video, and give this question a try. Okay, so let's have a look at the answer. Okay, so we know our P, it's 2,000. We know what our rate is, it's 5% or 0.05, and our time is 8 over 12, or you could simplify that. And that would give you 4 over 6 or 2/3. But you can easily leave it at 8 divided by 12. So we're trying to solve what our maturity value is, S. So we have our formula, which is S equals P multiplied by 1 plus RT, or 2,000, multiply that by 1 plus your 5% multiplied by your 8/12. Calculate that out, and it works out to be that the future value based on this information is $2,066.67. And we know that The principal is $2,000, so we can look at that and figure out that the interest amount is the $66.67 added to the principal. Okay, so if we want to figure out what the present value is, or the principal amount, where did we start? Okay, so we can arrange our maturity value formula to solve for the present value. So we know how much it is in the future, that's our S. If we don't know, if we know how much it is at the end, and we know our rate and our term, we can also figure out, well, what was our principal to begin with? So give this one a try. What amount of money would have to be invested at a simple interest rate of 3% per annum or per year in order to have 4,000 after 175 days? So we know that in 175 days, we need $4,000. And we've got information saying that if we put a certain amount in, we can actually earn an interest rate of 3%. So how much money do we have to invest in order to have the 4,000 at the end? So again, pause this video for a moment and give this one a try. Okay, so let's solve it together. We're given, we know at the end, the future value, we want it to be 4,000. We know we can earn a rate of 3% or 0.03. We know that the time or the term of this investment is going to be 175 days out of a possible 365, which is our year. So what is the present value? What is the principal amount we need to start with? So after our formula is rearranged to isolate the P, we know that it's P equals S divided by 1 plus RT. 4,000 divided by 1 plus our 3% multiplied by the 175 divided by 365. And that means that we will start with a principal amount of $3,943.28. If we wanted to, we could figure out how much interest. The question's not asking that, but we easily could, because our principal is the $39.43.28 and our future value is the 4,000. So the difference between those two would be the interest that was earned. Okay. Okay, so the time value of money. This is saying that money received at different points in times may have different values. Okay, so if you offered to give me $100 today, or you're going to give me $100 3 years from now, well, I'd rather have the $100 today because it's worth more. Okay, but if you offered me $100 3 years from now, it's going to have less of a value. And that's because if you gave me that $100 today, I could actually take that and invest it, earn interest on it, so that in 3 years' time, maybe it would have a value of $105. Okay, so that's what it means by the time value of money. Different time periods, the same amount of money, the value is different. Okay, so equivalent payments. An equivalent payment has the same value as another payment once interest has been applied. For example, using a rate of 5%, the equivalent payment in 1 year to $100 today would be $105. So they've applied the interest to it. So that, again, if it's $100 today, it's $105 in a year's time. Both amounts represent the same value, just a different point in time. We can use the maturity value and the present value formulas to calculate these equivalent payments. So this is like for a car loan, okay? The different values that you give. So let's try this. Bob had promised to pay Sally $1,000 on October 1st. Sally planned on investing the money into a GIC, earning 2.5%. Bob was late with his payment and couldn't pay Sally until November 10th. What would be a fair amount for Bob to pay? Give that a try and see if you can figure out what the answer is. What would be a fair amount for Bob to pay where he was late paying Sally? Okay, so let's give it a try. So Bob promised to pay Sally $1,000 on October 1st. So she could have taken that money then and invested it into a GIC for a guaranteed investment certificate. That's what GIC stands for, earning 2.5%. Bob didn't pay Sally on October 1st. He didn't pay her until November 10th. So she lost out on that 2.5% from the GIC. So in order to be fair, Bob should give her the value that she would have earned if it had been invested. So the principal amount is 1,000. The rate of interest is 2.5% or 0.025. The time frame is 40 days. You can use that chart, table 7.2, to calculate it, or you could put it in your into your calculator, your Texas Instruments, to figure out how many days. So 40 divided by 365. So now we can figure out what the maturity date would be. And that would work out to interest of $2.74 added to the principal to give $1,002.74. And that's how much Bob should give Sally on November 10th. Here's another one. Calculate the equivalent value at an earlier date. Bob had promised to pay Sally $1,000 on October 1st, but would like to pay her back a few weeks early, so on September 10th. What would be a fair amount for Bob to pay if Sally can invest his payment at a rate of 2.5%? Okay, so now instead of the $1,000 being the present value or the principal, we're looking at that being the future value because he wants to pay her early. So if he wanted to pay her today, how much would he need to pay her? So that would be the principal amount. So okay. So we need to figure out what the principal amount is. So again, it's your future value, your S, divided by the 1 plus RT, and that calculated out gives you a principal of $998.56. And the difference, if you wanted to figure what the interest was, it would be the 1,000 minus 998.56. Okay. And this is where we are going to stop. Thanks, everyone.